In this video, we'll learn how to keep track of significant figures in calculations, working through 6 examples including multiplication and division, and addition and subtraction. For multiplication and division, the sig figs in the result will follow the fewest number of sig figs in the measurements. First, we ignore sig figs in exact numbers. There are no exact numbers here. Then, we count the sig figs in each measurement. There are 3 in 1.01. The next two numbers have leading zeros, which never count. They also have trailing zeros, which do count because of the decimal points. So there are 3 sig figs in 0.340, and there are 4 in the last number. When we calculate the result, we get 8.58 times 10 to the negative 3. This value is rounded to 3 sig figs to match the fewest number in the measurements. Division follows the same process as multiplication. We count the sig figs in each measurement, 3 and 2, calculate the result, 0.13, and report the answer to 2 sig figs. With addition and subtraction, we don't count the number of sig figs. Instead, we count the number of places. The calculated result will have the fewest places. Like always, exact numbers never count. There are no exact numbers here. We'll identify the last significant digit in each measurement by highlighting the sig fig furthest to the right. Then, we'll compare the highlighted digits and locate the one that is furthest left. It has the fewest places. We can see that the 4.0 only goes out to 1 decimal place. When we calculate the result, it gets rounded to 1 decimal place, which is 240.4. Like addition, we highlight the last sig fig in each measurement. Here, the 140 only goes out to the tens place, so it has the fewest places. Its highlighted digit is furthest to the left. When we calculate the result, we will round it to this number of places. The answer is 60. When we have both types of math, we have to keep track of the sig figs separately for each mathematical operation. We'll start by dealing with the multiplication only, where the result will take on the fewest number of sig figs. The 1.8 is exact, so we ignore. The 4.3 has 2 sig figs, so the result, 7.74, gets rounded to 2 sig figs, which is 7.7. Now we take that intermediate result, which is properly reported, as the starting point for the addition. But here, we no longer care about the number of sig figs. Instead, we switch our mindset and mark the number of places. 7.7 has 1 decimal place, 32 is exact, so the result of the addition will be rounded to 1 decimal place, which is 39.7. In this example, we'll first deal with the sig figs for the subtraction only. 166.7 has 1 decimal place. 32 is exact, so the result gets rounded to 1 decimal place, which is 134.7. This properly rounded result now gets placed into the second step, which is a division. But here, we make the switch. Instead of counting places, we now consider the number of sig figs for this value. 134.7 has 4 sig figs, 1.8 is exact, so the answer will be rounded to 4 sig figs, which is 74.83.